and thank you for joining us on the webinar, The Science Behind L-Citrulline for Exercise Performance and Heart Health, sponsored by Kyowa Hakko, USA. I'm Karen Todd, a registered dietitian, sports enthusiast, and the Director of Marketing for Kyowa Hakko. I'd like to welcome and introduce our presenter, Dr. Danielle Citrulline. Danielle is a registered pharmacist and the Technical Services Manager for Kyowa. She holds a Doctor of Pharmacy from Albany College of Pharmacy in New York. Prior to joining Kyowa, Dr. Citrulline was the clinical coordinator at the Hospital for Special Surgery in New York City and provided support and guidance to the pharmacy staff on policies and procedures. Danielle, thank you for joining us today.
Hi, Karen. Thank you for having me.
In this webinar, Danielle will discuss how L-citrulline is converted to arginine in the body to support L-arginine and nitric oxide levels. She will also explain how citrulline supports nitric oxide production and has an effect on heart health and sports applications. We've made this webinar slightly interactive and have a few polling questions we will ask the audience during Danielle's presentations. We have a live Q&A that will follow. If you have questions during the presentation, please post them in the questions section. Let's get started. I'll turn this over to Danielle right now.
Thank you, Karen, and thank you, everybody, for attending today and listening. Hopefully we can get to your questions on citrulline at the end. And without further ado, let's get started and we'll talk about citrulline. So for today's talk, I plan to address what citrulline is, its metabolism, its pharmacokinetic advantages, most importantly, its physiological activities, and then I will briefly touch on its physical properties as well. So what is citrulline? Citrulline is an amino acid that is produced in our bodies. It's actually not a component of protein, unlike most other amino acids. And so because of this, previously citrulline was really thought of as just an intermediate metabolite, and there really wasn't a huge focus on citrulline. However, over the past decade, there's been a lot more research, and there's been a lot of dramatically increase in the literature, and we've learned a great deal about its metabolism and its important role in the body.
So we've come to our first polling question here. What food is naturally high in L-citrulline? Bananas, eggs, watermelon, or beef? So if you take your cursor and just click on which one of the foods you believe is naturally high in L-citrulline, I'll click on the results here in a second, and we can move forward. Give you about 10 more seconds. Okay, here we go. So 64% picked watermelon. Danielle, what do you think about that?
I'm thinking they're pretty smart. And here it is right here. You can see that actually citrulline, because it's not a part of proteins, you think it's probably not really in a lot of foods, and that's right, it's not in a lot of foods, but one of the major foods it is in is watermelon. And I have a list here of other foods that it's in, but really it's negligible amounts in the cucumbers and pumpkins and in the bitter melons and things, but the majority you'll find is in watermelon. Actually, the name citrulline comes from the Latin derivative of the word watermelon. So you guys were right. All right, so I'm going to go ahead and move on to understanding citrulline's metabolism. Citrulline is synthesized by our bodies in two places. The first way is represented with the diagram I have here. As you can see, citrulline is made from L-ornithine as a component of the urea cycle, and that happens in the liver. But the majority of the citrulline is produced by our enterocytes, which are the cells that line our intestine. And here, citrulline is actually synthesized from L-arginine or L-glutamine by the enterocytes. So what's the metabolic fate of citrulline? How is it metabolized? About 75% of citrulline in the bloodstream will get converted to L-arginine by the kidney, and that's the majority of where citrulline gets metabolized. Here I have an explanation of the exact pathway of its conversion. And you can see that once it leaves the kidney and the arginine hits the circulation, it actually is converted again into citrulline and nitric oxide, which in turn which serves as an L-arginine precursor. So I think it's important to emphasize that you notice that once it leaves the kidney, it's converted to arginine. It's converted to arginine in the kidney. Then it leaves, and it's converted back into citrulline in the bloodstream. So you can see that mechanistically there's a recycling and that is how citrulline supports nitric oxide metabolism. And so if you think about what we see is the higher input of citrulline into the kidney, the higher output of arginine out of the kidney, and potentially increasing production of nitric oxide. And then citrulline, again, possibly seeing a recycling of this process. Of course, we need some science to back that recycling theory up, but you can see mechanistically it is there. And this is just an outline of the normal distribution of citrulline in the body. It's mostly animal data, but I believe it gives us a really good idea of how well citrulline is distributed in our bodies. So let's learn about the pharmacokinetics of citrulline and some of the specific advantages of its pharmacokinetics. So the pharmacokinetic advantage of citrulline is that it's not subject to any elimination by our organs prior to entering the bloodstream. So pretty much 100% of citrulline can enter the bloodstream when it's orally ingested. However, with L-Arginine, it's subject to extensive elimination by the gut wall and the liver. So as you can see here, it's been reported that about 40% of the ingested arginine is metabolized by the gut wall and the liver and actually doesn't make it into our bloodstream. And as I outlined earlier, the main organ responsible for conversion of citrulline is the kidney. And in fact, it's only the kidney that converts citrulline into arginine. And as I mentioned earlier, it's about 75% of citrulline in the bloodstream goes into the kidneys. So you can see there's an advantage here from a mechanistic point of view. But let's understand it from more of a scientific point of view. So we'll take a closer look at the comparison of L-Citrulline and L-Arginine. This study was done in animals and rats, and they administered about equal doses of citrulline and arginine. And they measured the plasma levels of arginine following the administration. They did some preloading, about 3 to 4 days of the treatments, and then over a 12-hour period, they collected blood samples. And here's a graph that outlines the overall plasma levels of arginine in the blood over time, over that 12-hour period. AUC represents the total amount of arginine detected in the blood. So they look somewhat, you can see there's some spikes, but overall the citrulline remained higher, and the actual area under the curve, or AUC, of the citrulline group was much higher, as you can see by the number here. It's another way of graphing the same data, and it was statistically significant. So if we did some simple math and we took basically the both area under the curve and did a ratio of it, you'll actually see that citrulline was 1.6 times more effective at increasing the blood levels of arginine. So now let's see this in humans. And this was a really good study that was done in humans by Schwedhelm, and it confirms really what we just looked at. So we're looking at 20 healthy male and females, and it was placebo-controlled as well. And the subjects were supplemented for 7 days prior to taking the blood samples. On the 7th day, they took the blood samples and measured, again, we're measuring L-Arginine here. And as you can see in the graph to the right, the citrulline at the same dose as arginine was more effective at increasing the blood levels of arginine. This was statistically significant, the 3.2 as compared to the 3-gram group. And if we did a simple ratio again, the ratio is about 1.5. So very similar to the animal study, only confirming the animal data, which is really what we want. So since we're looking at pharmacokinetics, I figured I'd touch on some dosing. When you look in the literature, you're really going to find a huge variation in the dosing of citrulline, whether it's clinical or for physiological effects and exercise. The range is pretty wide, anywhere from 1 gram to 6 grams per day. We believe a nice median is around 2 to 3 grams. That's the dose we're kind of targeting. But of course, it's going to be dependent on your intended use. So more specific doses will be found in the studies pertaining to which physiological effect you're looking for. And often people ask us, when should you take it? And this also depends on the application. If it's for overall health and well-being, which you'll see some studies, coming up, you're going to see it dosed once a day. But if you're doing it for a targeted performance or athletic performance, you're going to want to do it prior. Sometimes there's loading involved too in some of the studies, so it all depends. But definitely prior to exercise or during is a good time to take it. We always need to touch on safety, of course. So because, citrulline occurs naturally in the body of both animals and humans, and we know it plays an important role, it's really regarded as pretty safe. We definitely have a great deal of human studies that have demonstrated that citrulline is safe. There is actually some long-term data as well. There was an experiment in patients with lysiniuric protein intolerance, and it was about 19 subjects, and they were given 2 to 2.2 grams of citrulline every day for 2 years, and there was no reported issues with that. So that's pretty good long-term data. In addition, we here at Kyowa have just received our self-GRAS determination, and as many of you may know, it's a rigorous process where you have to provide a lot of toxicology information. You have a lot of toxicologists reviewing the ingredient, looking for its safety, and so we can definitely determine that this is a safe ingredient. So now we're going to move on to the important stuff, the physiological activities. And as I mentioned earlier, there's been a lot of research on citrulline, especially having to do with physiological activities. And there's a variety of research and many different applications, so I'm going to get into those specific applications.
So this is a question for you. We are curious to see how many of you that are on the phone today are planning on formulating or reformulating a product, either sports nutrition or heart health, in the near future, possibly in the next 12 months. And if you would just quickly click on either yes or no, we could pull up this polling question pretty quickly. So I'll give you a few more seconds. Okay. Let's see how it came out. So about 55% are planning on looking at reformulating or formulating a product, and 44% are not at this time. So great. That's good to see. Thank you. We'll keep moving.
Yeah, we're happy to hear that. So, so as I mentioned earlier, there's been a lot of research on citrulline, especially having to do with the various physiological activities. And however, there's so many, and it's really hard to kind of pick what to focus on because there's just a lot of research going on right now. But for today's, talk, I'm just going to focus on the 5 that I think that are not only useful but seem to be the more promising or prevalent area of the literature at the moment. So I'm going to look at citrulline's role in supporting nitric oxide production, vascular health, muscle protein synthesis, ammonia elimination, and I'll touch a little bit on immune function as well. There's quite a bit of literature that exists, as I said, in all these areas. But I'm not focusing on the actual literature. Some of the things I brought into this webinar today is actually new research that some of which might be unpublished. It's done by our research group, and we're working on publication. And I thought, you all can look through the literature yourself, but I wanted to present to you some new information regarding these different areas from our side. So it's exciting and it's fresh data that you can look forward to seeing published in the next year. So we'll start our discussion about nitric oxide production. And if you think about the metabolism and the pharmacokinetics I just showed you, it makes a lot of sense that citrulline has a role in the production of nitric oxide. We know the mechanism, but I want to take a closer look now at some of the studies that show that the physiological effects support the mechanism. So first we'll take a look at some preclinical data. This is data in rats, and they were given either citrulline, 500 milligrams, or a control. And using an indwelling catheter, the nitric oxide metabolites were measured to evaluate the effects of citrulline on nitric oxide production. So you can see they were preloaded about 3 days, and then they did a 4-hour collection of the blood samples to look for the nitric oxide metabolites in the blood. And so as you can see by this graph here, the citrulline did have an impact on the nitric oxide production, and it was found to be statistically significant compared to placebo. And this is actually one of our in-house studies that we're working on publication on, and so hopefully we'll see that this year. So it's always important to confirm our preclinical studies in humans. So to confirm what we just saw, we have a study here in humans, 17 healthy male cyclists, and they're actually very well-trained cyclists. They were given either a control drink or a drink of citrulline with 6 grams in it. Again, you see the range of the doses. They were to complete a rigorous 137-kilometer cycling test, which is pretty far. And again, they measured in the blood the nitric oxide metabolites as an indicator of nitric oxide production. So as you can see in the graph on the right, the citrulline group was significant in increasing the plasma nitric oxide generation right after exercise, and I think what's pretty impressive is even 3 hours post-exercise, you still see a statistically significant increase or elevation in that nitric oxide production. So that was a rather positive study to see in humans.
Okay, now this is our last polling question. We are curious on the interest in the vascular health or the heart health category with citrulline. And if you take your computer cursor and click on yes or no, how many of you are primarily interested in citrulline's role in vascular health? I'll give you a few more seconds to answer that. Okay. This is very interesting. 78% are very interested, so this is good news. Danielle, back to you.
Yeah, that's great news. I think you're really going to like what I'm about to show you. So, you know, as I just showed you, as a result of that nitric oxide production, we know that happens as a mechanism. You can understand there would be definite potential for citrulline to support the vascular health. There's a pretty good amount of literature in that area. Of course, more is definitely needed. But today I'm going to show you 3 studies that are in-house, and few are one is published, and a few are looking for publication soon. So this will be good. So the first study here I wanted to share, the publication is in progress, and in this study we have healthy females that suffer from poor circulation and can be extremely sensitive to cold. I know I'm one of those people sometimes. And the citrulline was supplemented in subjects. They took about 3.2 grams of citrulline, and they did the loading again. They did the 5-day prior to the test day. They took it every day. And then on the test day, they took it in the morning about 1 hour prior to the test. And what the test was it was a cold water submersion bath. So they took the hand, they submerged it in the bath, and then after removing it from the cold water, they used a laser imaging technique to detect the peripheral blood flow while the blood flow increases to warm the hand back up to our body's temperature. So here are the results of that study, and as you can see, as a comparison to the baseline, the treatment group was much better at improving the blood flow after that cold water submersion. In fact, it was higher, but it was statistically significant and a big difference at 14 minutes, which is pretty good. And you can even see that in the imaging to the right here, you can see the difference from baseline. You know, the blue and the purple represent cold, and you can see that there was a lot less, and even warm towards the 14-minute. You can see the significance there. So definitely helping with blood flow and blood volume in this, quick little experiment, which is pretty impressive. And that one, like I said, is looking to be published in this year. So here's another study in-house, and in this study they used both male and females, but they only used one single dose of citrulline. They were given 800 milligrams only once. And after the dose was given, they began to measure the changes in body temperatures about 20 minutes after they were given the dose. And they used a thermography technique to measure the changes in the body temperature. It was a crossover study, so you see that subjects, that were in placebo then got citrulline and vice versa. So that's always good to see. And as you can see here, you can see that the citrulline group showed a significant increase in raising the body surface temperature. You can tell by the graph, and it was statistically significant at 90 minutes, but there was a nice trend at 30 and 60 as well. And the conclusion was that it definitely increased the surface temperature in the neck, and the shoulders, and the palm, and specifically the right palm. So that was a pretty neat study as well. The next study was actually just published in 2013. It was also done by our group. And here they looked at subjects that had a diagnosis of vasospastic angina, so it's kind of constriction of the blood vessels around the heart. And with this study, there was 22 patients altogether, and they took 800 milligrams per day of citrulline over a total of 8 weeks is when they were given the treatment. The endpoints in the study were the changes in FMD, which is called flow-mediated dilation of the brachial artery. The brachial artery is the major artery in the upper arm. And flow-mediated dilation is basically a non-invasive way to measure the blood vessels dilation. So we're wanting to see that citrulline is having that effect via the NO mechanism and dilating those blood vessels. And this FMD is done by an ultrasound technique. They also looked at ADMA, and if you read any of the citrulline papers, you'll see in arginine, you'll see them talk about ADMA, which is it's a compound that is considered an inhibitor of endothelial nitric oxide synthesis. So it competes actually with arginine for the active site of the endothelial synthesis. So we don't really want that ADMA around because it's going to inhibit NO production. So in this graph, you can clearly see that there was an improvement in the dilation of the brachial artery. This is the FMD, as I mentioned, and there was statistical significance at 4 weeks and 8 weeks. So what I think is really interesting in this, too, is that at 12 weeks, they continue to measure and look at the changes, and you still see a pretty significant increase compared to baseline of that FMD, even, 4 weeks later. So that's pretty cool. Even after they stop, you're still getting the upregulation of the nitric oxide. And as I mentioned earlier, the ADMA inhibits the nitric oxide synthesis, so we want to see a decline in ADMA. And actually, they were able to detect that at 8 weeks at a statistically significant decrease in the ADMA. So that was really great data. Another measurement that you'll often see in the literature, too, is the ratio of arginine to the ADMA. And obviously, you want more arginine around because that's going to promote the nitric oxide, and you want less ADMA around. So the higher the ratio, the better. And you can see with the graph on the right, we did see a statistically significant increase in the ratio at 8 weeks within this study. So that was really positive. And one of the other endpoints they found was a decrease in the oxidized LDL. And I was a little perplexed with this information at first because I just didn't understand why you would really affect oxidized LDL initially. And obviously we want to decrease oxidized LDL. Oxidized LDL is the key component of thrombotic events, and it actually activates adhesion molecules, so less is definitely better here. And so when I looked into it a little bit more, the mechanism or the thought process behind this is that nitric oxide itself actually has a potent antioxidant property, and it's actually possibly inhibiting the oxidation of the LDL. So you can see that the potential increase in the nitric oxide is most likely responsible for inhibiting the oxidation of the LDL. So that was a really positive, and that's pretty significant decline as well. So interesting stuff. So now I'm going to go ahead and take a look at protein synthesis in relation to citrulline. So here we have a study, again, preclinical, looking at rats, and what they did was they dosed citrulline at 6 grams, and they dosed the non-essential amino acid mixture. But before they started it, they did a 12-week period of 50% food restriction in 30 rats. After 12 weeks, 10 of them, they stopped and they did muscle biopsies. They continued for another week in the other 20, and they separated it 10 and 10 group. 10 of them got citrulline and 10 of them got the non-essential amino acid. And they refed them at the normal baseline level, but they included the citrulline and the non-essential amino acids. And so then what they did was they took muscle biopsies. And as you can see, absolute protein synthesis was actually much greater in the citrulline fed rats as compared to the restricted rats and even the non-essential rats. And this one was statistically significant for the absolute protein synthesis. There was other measurements and endpoints in this study if you want to look it up, but I pulled this absolute protein synthesis out as it's pretty to the point. So you can see it's definitely having an effect on protein synthesis. And of course, we always want to confirm preclinical in humans. You know, as I said earlier, citrulline data is, still kind of developing. So I didn't find a lot, but I did find this abstract still yet to be published in 10 healthy subjects. And what they did was they started with 3 days of the low-protein intake diet, and then they were randomized to take either citrulline or, again, the non-essential amino acid mixture. And they took it, and then they measured their protein. After 8 hours of ingesting it, they did muscle biopsies in humans, which is never fun. So, but the conclusion of the abstract showed that for the first time in humans, in healthy humans, citrulline ingestion stimulated the muscle protein synthesis without affecting whole body protein turnover was their determination. So hopefully we'll see that getting published at some point. So next we'll touch on ammonia elimination. And just by mechanism, this really makes sense of how, because we know citrulline is involved in the ammonia detoxification, as that's really one of the major roles that the urea cycle has. You can see the toxic ammonia here, the NH3, and that's one of the ways the body gets rid of ammonia. So being part of that urea cycle and increasing the citrulline levels is really going to amp up or rev up this cycle and help to eliminate that. And there's a slew of experiments in animals showing that citrulline can, promote the metabolism of the ammonia and the accumulation during exercise. In humans, we don't have that data quite yet, but we do know it's been used in clinical settings to alleviate hyperammonemia in subjects that have encephalopathy and different disorders. So we don't have the exercise in humans yet, so that's something we can look for in the future. But we know it's going on in humans, and it's effective physiologically in humans as well. So next I'll just touch on the immune function, and this is probably the area that has the least amount of literature at the moment, but I think it's probably the most interesting and the most promising, and hopefully we'll see more get published. In fact, most recently I'll talk about it. There was a publication in this area, but there's been studies that have showed that citrulline may be responsible for decreasing pro-inflammatory cytokines like IL-6, but they don't impair the overall anti-inflammatory mediators that we want to happen, to protect our bodies. And also there's been studies that have reported that citrulline looks like it might support the T-cell proliferation. So that's really neat. And one study that I actually wanted to add to this was just published in December. And the study was actually looking at citrulline's protective effects of the kidneys in a diabetic animal. It was in rats again. And so they actually concluded, and they found the specific cytokines that it affected, and they concluded that citrulline has an anti-inflammatory profile. And in this case, it significantly preserved the nephron function in the rats. So that was another study that showed it's definitely having an anti-inflammatory effect in certain cases. So pretty exciting. Looking forward to seeing more in this area. So I've touched on, briefly a lot of these different physiological effects of citrulline. And when you consider all of these actions working together, you can really understand that, it can have a huge implication on overall health, vascular health, and fitness. So we're really looking forward to more literature and more science in this area. And today I was a little brief with the science I presented, but we have just recently published a white paper, and in that white paper I go into a little more detail and definitely provide a lot more of references and literature that you can look further into whatever specific area you're looking at for your formulating or your interest. So for today's take-home, I definitely hope that you were able to take away that citrulline is more effective at raising the blood levels of arginine than arginine itself. It has important roles in nitric oxide production, vascular health, muscle protein synthesis, ammonia, and immune function. And we believe that citrulline supports overall health and fitness. But before I finish, I think it's helpful to touch upon the favorable physiological properties of L-Citrulline as a raw material ingredient. So here's a quick look at the basic physiological properties of citrulline. One of the things I want to highlight is that it is non-hygroscopic. So that's kind of a big thing we hear a lot of complaints about when from customers with different products when it's hygroscopic. And our citrulline really is pretty non-hygroscopic. So we really kind of like to let everybody know about that. And it really has to do with tableting, too. I mean, this is one of our own in-house data showing that, citrulline tableting is much easier than arginine itself. Of course, you can, make adjustments and pulverize the arginine, to make it tabulate better, but, you don't have to do that with citrulline. It's pretty easy to work with. And going beyond that, we just have a lot of data on stability. This is one that shows the stability of the powder at various temperatures. This is looking at the residual rate of citrulline at really high temperatures, 160. Of course, this is the powder, and then we actually have the solution here too. This is a 2% solution heated at different pHs and at 95 degrees Celsius, pretty high for 15 minutes. It was a shorter one, but we have a good amount of data showing the different ways, stability and ways we can formulate. And this is a combination product showing that citrulline is compatible with other ingredients in a granule formulation. And there's more, too. I just wanted to give you a brief glance at some of the stability data that we do have in the formulations and kind of give you thoughts to different formulas that you could come up with. So as I mentioned earlier, this is a brief glance at our white paper. If you're interested in more detail, or if you even have questions about what I presented today, I was a little brief on some of it. If you have questions, feel free to shoot us an email, or if you'd like our white paper, definitely let us know. And without further ado, thank you guys again for joining, and I guess we can go ahead and start some questions.
Yeah, we'll start the Q&A right now. We have several lined up right here I'll go through. But if you do have a question, please put it in the Ask a Question section and submit it to us, and we'll get to it. Danielle, thanks for going over the physical attributes of Kyowa's product. I think that was really important. We were getting a lot of questions about that. There's been some information in the research about watermelon containing citrulline. Can you talk a little bit about eating watermelon versus taking citrulline alone?
Yeah, there's actually, I don't know if anybody's seen, but there's some literature out there talking about watermelon and showing that watermelon can be effective in the vascular health world. And I think, that's positive because there is a lot of citrulline in watermelon. However, I probably wouldn't recommend that to be the way that you supplement if that's how you want to do it, just because, it's probably unknown how much is getting ingested. And even if you think every watermelon is going to be variable. So you really don't know, how much you're getting. And if you're looking for a targeted specific effect, you're going to want to target that dose. You're going to want to know and be effective at what you're looking to achieve.
That's good to know. Could you talk a little bit more about Kyowa's citrulline and how it's different from other citrulline products or even citrulline malate?
Oh, yeah. So Kyowa's citrulline is actually produced by fermentation. So it's It's not done by an extraction process or an enzymatic reaction, which is definitely favorable when it comes to like its impurity profile. It's non-animal, which I think a lot of people like. And as I mentioned, I think having the fermentation process and really producing a pure product helps with that physical properties I was talking about, like the non-hygroscopic. And of course, we have all that stability data. And I think you mentioned the citrulline malate, how it differs from malate, right? Yeah. Well, citrulline malate is just the salt version of citrulline. Generally, we don't consider salts to have a huge difference in mechanism of action. FDA definitely doesn't think so. In theory, the thought is that citrulline, either the malate is responsible for energy production. Whether there's enough malate to actually do that, that's never been really looked at. But definitely based on the literature that's out there, we know exactly what citrulline's physiological role in the body and that it's producing the nitric oxide. So, from my perspective, we know that citrulline is the component that's responsible for those effects. So that's the way I look at it, the difference. So.
Oh, that's good. Thank you. We have a question about the blood-brain barrier. Does citrulline pass through the blood-brain barrier, and if so, does it take larger doses, and do these doses upset any type of amino acid balance in the brain?
Well, of course you're gonna be able to pass the blood-brain barrier only because amino acids are the building blocks to all proteins and structures in our body. So definitely, you're going to have citrulline in the brain as a part of the normal metabolism that goes on, and ammonia elimination and things like that. And I know for a fact, in fact, encephalopathy was which is enlargement of the brain, one of the treatments for hyperammonemia. So definitely it's effective at passing the blood-brain barrier. But, our body has a really amazing way of, balancing what it needs and what it doesn't need, and it's going to shunt when it becomes out of balance. And especially it protects, that blood-brain barrier is very good at protecting the brain and not allowing too much imbalance. So I think what you're going to do if you overdose or get too much, I don't think you're going to affect the brain. You're probably just going to work your kidneys a little harder because they're going to be metabolizing that citrulline to excrete it and get rid of it. So I don't really see it upsetting the balance of the brain as much. Your body's going to work harder to eliminate it and make it in balance.
Great, thank you. And we're getting many questions about the slides. The slides will be available right after the presentation, so those will be available as a PDF for you to download immediately, or you can always email us for a copy of the presentation. That's not a problem at all. Daniel, a question came up of where do we actually produce, where does Kyowa produce our citrulline? Where is it manufactured?
The majority of the citrulline that we produce is actually manufactured in the U.S. We have a plant in Missouri that manufactures it by fermentation, and so it is a U.S.-based product.
Great. And you did mention and talk a little bit about citrulline versus arginine. Is there a preference for one over the other, or is it just kind of what you're looking to do in a formulation?
Yeah, I definitely think it depends. I mean, I wouldn't say one is necessarily better than the other at this point. I mean, it still kind of just depends on what your goal or your target or intention is. But I definitely encourage everybody to think about the advantages of a citrulline that, probably a lot of people didn't know before. And then I think it's just coming to light that, citrulline has the advantage of not being metabolized prior to reaching the systemic circulation, and that there's a good amount of literature now that shows that it's more effective at increasing arginine levels. So if that's something you're looking to do, you might want to consider citrulline.
Great. Let's see. Are there any benefit, or I guess any issues with taking too much citrulline?
So there's been, toxicology reports, and, there's been, actually, if you look at the literature, there's been pretty high doses of citrulline administered without any trouble. Obviously, a lot of things are toxic in really, really high levels, but this has like I said, we just got our self-determined GRAS. We had a lot of toxicologists looking at it in all the toxicology reports, and overall it's definitely deemed safe and healthy, and like I said, there's been a lot of studies with even high doses showing no potential concerns. So.
And can you combine citrulline with other nitric oxide promoters into a formula? There's a lot of questions about combining or which one's better, and I think you kind of addressed this as well. But are you getting too much nitric oxide production if you put too many products together?
Yeah, I think that you're going to see, I mean, I think a combination is definitely great because you can tackle it from different mechanisms. That's not a bad thing at all. No matter what, your body is going to have a max at how much it's going to allow you to produce. You know, you can bump up your nitric oxide production for sure. You can increase it, but even in the drug world, I'm a pharmacist, there's only so much nitrates you can give a patient, and then they kind of hit a wall. Your body's not going to make any more than this because it's not safe. So, yeah, you can target different directions with different ingredients, but, overloading it is not healthy, and you're really going to become ineffective at, you're not going to get more for your money, really.
And could you review the doses one more time? I know you went through them pretty quickly in the middle of the presentation, but what are the recommended doses?
Yeah, I mean, it's a tough question, and I'm sure this is why we're getting a lot of questions, because really when you look at the literature, the doses are really spread out. They're everywhere. I mean, you'll see anything. The common, I think, range is anywhere from 1 gram to 6. I mean, you saw a lot of our studies had 800, which is great to see, like, lower doses being effective, which is what I would like to see more in the literature, is starting to trend towards the lower doses, the 1 and the 2 grams, to see how effective we can be. But some of the studies, especially in the exercise studies, they're pretty high, 6 grams. I think a target of like 2 to 3, that middle, is a safe way to go, a nice middle ground. And then there's a good amount of literature in that area. But again, it just depends on what is your formulation targeting, and then you got to round up all the literature in that area and kind of make a consensus on what the safe dose is and what a target dose would be. So if you guys have questions specific to one area, I'm happy to help kind of look at that and recommend something. But of course, it's always going to be the literature that needs to back it up. So.
And that kind of leads us into a couple other questions. Is there any research for citrulline and pulmonary hypertension that you've come across?
There's a lot in the hypertension area. I haven't seen pulmonary hypertension, but it would make sense that it would have a little bit of efficacy, as the artery is still going to have some vasodilation effect. But I don't think, off the top of my head, I don't think there is any, but I can't be sure. But there is some antihypertensive studies out there. And, overall, it's still, I think there's still more studies that need to be replicated to really show its effect. There's, kind of the literature's all over the place right now with hypertension. We need some bigger studies done.
Right. And there's one more question here on, because you showed the hands and getting more blood flow to the hands. Has this been looked at with Raynaud's disease?
No, but that would be a great one. I was thinking about that as well, because I worked in a rheumatology center briefly, and they always walk around with gloves. But yeah, that seems like that would be a great, I mean, a lot of people that have cold extremities, there's a lot of different diseases and issues in that area. But yeah, it seems like it could be potentially effective. And even if maybe we could even do a study with a little higher dosing to see could it be even effective. And getting subjective information from the patients or subjects too would be interesting to see. Did they feel warmer? Did they, so that would be like a next step or something that I would think of to do. Would be nice to see. But logically, definitely would be an area.
Sure. No, that makes sense. I appreciate it. Thank you. Again, we're getting many questions about the slides. So again, they're going to be posted as soon as we're done here, and we're going to wrap up. There are several questions on dosing, and I think we've kind of gone over that as well. Interesting information on stability, and I think you'll see that in the presentation once it's downloaded. But if you have anything very specific you'd like to ask us, just send us an email at info@kyowa-usa.com, and we'd be happy to follow up with you on those specific questions. I don't think they're going to cross over to everyone, but I know there's some technical questions on stability, international use, and what markets it's available for sale in. So with that, I'd like to thank everyone for attending and Kyowa Hakko for sponsoring this webinar. I think it was a nice opportunity to get out some of the new information and learn a little bit more about what you're looking at, and I think this has been very helpful for everyone who's on the call today. Again, if you have any more specific questions, you can always email us at info@kyowa-usa.com, and the PDF of the webinar will be available right in a few minutes here. Thank you again, and have a great day.